Hello YouTubers. In the last video, we looked at some Python interview questions, higher order functions using list, nested list, and map. In this video, we'll look at a Python interview question, use it as an argument to a higher order function using Python's built-in filter function. I'm going to try to keep this short and informative, and hopefully you'll find something useful out of it. So let's go ahead and move over to our workspace and see what we got. So what we're going to start with, abundant numbers. And here's our problem description. An abundant number is any number whose proper function, proper factors, sum is greater than the number itself. So we're going to write a function that's going to print it is an abundant number if the number is abundant. It is not an abundant number if the number is not abundant number. Okay, so this, for what it's worth, this is the actual Python interview question in the series that I worked through. So we sum up the factors, we compare it to the number. If it's larger, it's abundant, otherwise it's not. Let's look at a candidate solution, or actually the solution that I wrote. Simple, basic, straightforward. We just have a iterate through a range up to number. Use some modulus arithmetic to determine if it's a factor. And then we do some conditional logic here. And as per the specification, we print out a statement. It is either an abundant number or it is not. Okay, so what we're going to do next is we're going to refactor and repurpose as abundant. And we're going to want it to return just a Boolean value rather than a statement. And then we'll be able to use it in the new higher order function as an argument. And consequently, the abstraction makes it easier to follow the code. So let's see what we get. With refactor, using list comprehension, we still have our range function, we still have our modulus conditional logic. But in this case, we're returning a Boolean, true or false, and not statement. Now we use it in a higher order. So it's like kind of why check for one number at a time when it's just as easy to look for all of the numbers at once. And where do we go from here? We have our initial function that is now going to be the argument passed to our new function abundance. Here's our built-in filter function, which just takes a function as an argument and it lists numbers as an argument. It returns an iterable object, which we convert to a list when we return it. Okay, what's next? So to complete it and make it fully functional, high-level program that runs at the command line or importable to a Python module, we'll go ahead and flesh out the rest of this. First, we have our shebang notation to invoke the interpreter, our functions, and we've added a main function which generates some test numbers between 10,000 and 20,000. Is abundant is our function that's being passed and our list of numbers that we just generated. Now we have this notation here, which you should be familiar with. It allows you to run the module as a standalone module. If the name of the module is equal to main, it'll call whatever's right here. So what's next? Well, the only thing really left to do is to run it and see what we get. Okay, we're going to wrap it in the time module and we'll keep track of how long it takes to process. Generally, it takes somewhere between 7 and 10 seconds to complete, which for 10,000 numbers is quite a bit of time. Yeah, okay, it took 11 seconds this run. So where do we go from here? Well, our next step, logical step, is to look at optimizing. And there's a few ways to do that. And the first way we're going to look at is, and this will apply to all our future functions, we're going to look at a data structure. The next data structure we're going to look at is the NumPy array. And it's optimized for processing arrays. And well, that sums it up. Let's just keep this short, wrap it up right now. I hope you got something out of this. If you did, go ahead and leave a thumbs up in the video and I'll try to do better on the next one. Thanks for watching.